In this video, we're going to be taking a look at question number 5 from our equation of a line practice sheet. So this is the last question we're going to be doing together. It says a mechanic charges an hourly rate plus the cost of parts. A repair that takes 5 hours costs $450. A repair that takes 7 hours using the same parts costs $530. Calculate the mechanic's hourly rate. So this type of question is very similar to what we learned how to do in unit number 3. It's been a little while, but it uses the same ideas as what we're doing in this unit. So when it asks for the hourly rate, the rate is rate of change. And the word that we've been using in this unit for rate of change is slope. So what it's really asking us to do is find our rate of change or our slope. Now it's up to you how you want to think about it, whether you want to write M for slope, whether you want to write ROC for rate of change. We've done both. They use the same formula. So I'm going to say my rate of change is delta y over delta x, right? It's the same formula for slope, it's the same formula for rate of change. Now, normally they would tell me in the question what it is. Here they haven't told me in the question what that rate is, so it's up to us to calculate it. What they did tell us was how many hours they worked and how much that cost. So I am going to make a table of values for the hour that they worked, and then the cost of how much it was. I guess that would be hours. There we go. So for 5 hours, it was $450. And for 7 hours, it was $530. We are going to find our differences. So to get from 5 to 7, I added 2. To get from 450 to 530, I am going to calculate 530 take away 450, and I get 80. So we went up 80. So it cost $80 extra for 2 hours of work. Okay, when we're doing our calculations, this side is always our x side, so that's our delta x. This side is always our y side, so this is our delta y. So we are going to end up doing $80 divided by 2 hours, which will give us $40 per hour. So the mechanic's hourly rate is $40 per hour. So I'm just going to say their rate is $40 per hour. Okay. Our second question says calculate the cost of parts. The cost of the parts is the initial value, also known as the y-intercept, right? So here we are calculating either the initial value or we're doing the y-intercept. It depends on what you want to think of it as. They're the exact same thing. The only thing is we're going to have to calculate. So to calculate the initial value, there's 2 different ways we can do it. We can use the method we've been doing in this unit where we use an equation, or you can use the method that we learned in unit number 3 where you work the table backwards until you get to hour 0. So it's up to you. Whatever makes the most sense to you is what you should do. I would like to try doing it with the equation, but you can also work the table backwards if you need to. Okay, so to get my initial value, or in this case my b value, I'm going to create an equation. So I'm going to do y equals mx plus b. So if I do y equals mx plus b, I need to pick one of the points in the table. So I can either do the 5 and 450, or I can do the 7 and 530. I think I might pick the 7 and 530 just because they're on the bottom. This one's the x, this one's the y. And I already know that my slope is 40. We just calculated that. So my y value is 530 equals m, so 40, times x, which is 7, and then plus b. So 530 is 40 times 7 is 280 plus b. If you would like to flip that equation around, you're welcome to do that. I would do b plus 280 equals 530 if I was going to turn it around. So I would subtract 280 from 530. So 530 take away 280 is 250. So the cost of the parts is $250. So I'm going to say the parts cost $250. All right, from there, the last two questions are a little bit easier. We've done all the hard work up front. I do just want to mention there were some other ways that we did this. So it is $40 an hour. So you could work your way back up the table, going up by 1 hour at a time. So you could go 5 hours, then 4, then 3, then 2, then 1, then 0, and then subtract 40, subtract 40, subtract 40 all the way back. We also talked about back in the day that you could do 450 minus $40 5 times, right? So 450 minus 40 times 5, which is essentially the calculation we ended up doing when we did the equation. So just some different options. But part C here says determine equation for the cost of the mechanic. They didn't give me letters to use, so I can use y and x. I could use C for cost and N for the number of hours. It really doesn't matter. I think I'm going to use y and x just because that's what we've been using lately. So I'm going to say we have y equals our slope or rate of change, which is 40, and then times x, and then plus my y-intercept or initial value, which is 250. The way we did it back when we did this unit in Unit 3, we might have written that C is 250, right? That's our initial value to start, plus $40 times N hours. Either one of those equations is fine. Whatever you're more comfortable with is what you should use. Okay, our last part here says calculate the cost of the mechanic if it takes 10 hours to do the job. So 10 hours, depending on which equation I'm using, is either the x, right, because that's where the number of hours is, or it's n, right? So we're either putting it in for x or we're putting it in for n. It depends on which version of the equation you are using. So I'm going to do y equals 40 times 10 plus 250. 40 times 10 is 400 plus 250, which is $650. So it would cost $650. So it would cost $650. Okay, so there are practice questions for you to work on for the rest of the period.